live tuition. Can you hear me? Yeah, okay, everyone, please turn on your camera quickly. Please turn on your camera. Yeah, good evening, all. Okay, is there anyone who is attending this class for the first time? If you are new to my class, can you please raise your hand? If this is your first maths class, please raise your hand. Any hand raises? No. So you all were there in the last class. So last class we were discussing about something. What was that? What was the topic that we were discussing? Geometrical. Yes, good evening. Last class we were discussing about zeros of the polynomial, of course, and geometrical meaning of zeros of the polynomial, right? Yes. So we were discussing about the geometrical meaning of zeros of the polynomial. Suppose we are drawing the graph of this of a polynomial. Okay, we are drawing a graph, and that graph represents a polynomial. And that graph or that curve or line or a parabola which is formed over there is bisecting or intersecting the x-axis at, say, 3 points. Can you say something about the number of zeros of that polynomial? So we just draw a graph, okay, and that graph is representing a polynomial, and that graph is intersecting the x-axis at 3 different points. Can you say something about the number of zeros of that polynomial? Sir, can I see the chat box? Yes. Yeah, we have a hand raise. Yes, Evelyn. What can we say about the number of zeros of that polynomial?
It is passing in three points EXX. That means there will be 3 number of zeros.
Yes, very good. That polynomial has 3 zeros. Yes, Bhagat, correct answer. So that polynomial has 3 different zeros. So anyways, we were discussing or we were dealing with chapter number 2, polynomials, and last class we discussed about the geometrical meaning of zeros of a polynomial, and as we all know, the number of zeros of a polynomial is equal to the number of intersections that graph has with the x-axis. Okay, so here let p of x be any polynomial. We have some polynomials, say p of x. Then the number of those points in which the graph y is equal to p of x intersect the x-axis is called the number of zeros of the polynomial, and coordinates of these points are called the zeros of coordinates, not coordinates, x coordinates. Yeah, x coordinates of these points, they are known as the zeros of the polynomial p of x. Okay, so here we have some graphs. Let's consider them one by one, and you have to tell me. Yes, good evening. You are late to this class? Break. Okay, guys. Yeah. So please do find the answers. We have 6 graphs here, and you have to find the number of zeros all this polynomial has in each of the following cases. We have 6 different graphs, and you have to find the number of zeros in each case. As we know, the number of zeros is equal to the number of intersections that graph is having with the x-axis. So in each of the following cases, you have to find the number of zeros. Yeah. So, yeah, okay. You have 2 minutes time, find the answers. After that, I will call you one by one and you have to tell me the answers. Yeah, so here we have the first graph, and in this graph we can see a parabola, and we know that a quadratic equation can be expressed. Yeah, okay, 1 second guys. Wait a second. Okay, so here in the first graph we can see a parabola. What about a parabola? It represents, anyways, it is representing a quadratic polynomial. Then the second case we have a line segment, which means it is representing a linear polynomial, because when we are drawing the graph of a linear equation, we will always get a straight line. Yeah, then we have another curve. What about the number of intersections? Then we have some more curves. Yeah, we have 6 graphs in total, and all these graphs, they are representing polynomials. We have to find the number of zeros in each case. Okay. What about the first one? First one. Okay, can you please comment your answers? Sir, is it possible to unmute someone?
Yes.
Okay.
Devananda.
Yes, Devananda. What about the first graph? Number of zeros.
Ma'am, the first one is 2 zeros.
Yes, very good. Here we have 2 points of intersection. Therefore, the number of zeros is also 2. Very good. What about the second one? Let's unmute someone. Second one.
Yes. It's Indian.
Yeah. Yes, Indian.
Yes, ma'am. There is no zeros for
Wha-
this polynomial
Why?
because the line doesn't intersect x-axis.
Yes, very good. This line is not even touching the x-axis. It is not intersecting the x-axis. Therefore, here in this case, this polynomial has no zeros. Very good. What about the third one? Third one. Yes, sir. Please unmute someone. Third one.
Hanok.
Yes, Hanok.
Band 3.
3. Very good. Here we have 3 points of intersection. Therefore, number of zeros is 3. Very good. Now, the fourth one. Yeah, this is first, second, third and fourth. Now, let's consider the fourth graph. What about the fourth one? Yes, sir.
Yes. Roshni.
Yes, Roshni.
Ma'am, 3.
3. Yeah, here also we have 3 points of intersection. Therefore, the number of zeros is also equal to 3. Yeah, now let's consider the fifth graph. Okay. Let's unmute someone, sir.
Yes, Ange.
Yes, Ange. Number of zeros.
Yes, ma'am. For the fifth one, it's 1.
1. Very good. Here it's 1 because there is only 1 point of intersection. Now the last one. Here we have the last one. Number of zeros. Last one. Yes. Can you unmute someone?
Yes, Sumaya.
Yes, Sumaya. What about the number of zeros of the sixth polynomial?
Ma'am, 4.
4. Very good. Here we have 4 intersections, 4 points of intersection. Therefore, the number of zeros in this case is 4. Okay. So, last class we were discussing about this one, geometrical meaning of zeros of the polynomial, and I think it is clear for you. Okay. In order to find the number of zeros, you have to look for the points of intersections. Okay. If the graph or the curve is intersecting the x-axis at 4 different points, which means that polynomial has 4 different zeros. Okay, anyways, let's leave this and now let's move on to the next topic, relationship between the zeros and coefficients of a polynomial. Okay, relationship between the zeros. So we know what is the zero of the polynomial, any value which makes that polynomial zero. Right? Suppose we have a polynomial, say p of x, and we have any number, say k, and if p of k is equal to 0, then we can say that this k is known as the zero of this polynomial. Okay. And what about the coefficients of a polynomial? Suppose we have a polynomial 2x squared minus 3x plus 2. What is the coefficient of x squared here? What is the coefficient of x squared in this one? 2x squared minus 3x plus 2 is the polynomial. What is the coefficient of x squared? It is 2. Yes, it is 2. Yeah. So, and here we have some relationship between the zeros and coefficients of any polynomial. So, this is a quadratic polynomial. Let's start from a linear polynomial. Okay. Let's consider a linear polynomial. For example, 2x plus 3. Okay, let's consider a linear polynomial 2x plus 3. Okay. Can you find the zeros of 2x plus 3? What about the number of zeros of a linear polynomial? Number of zeros of a linear polynomial? Yeah, sir, if you know the answer, you can raise your hand. What about the number of zeros of a linear polynomial? Number of zeros of a linear polynomial?
Rehan.
Yes, Rehan. Number of zeros of a linear polynomial. Rehan, can you please unmute?
Yes, ma'am.
Yeah, number of zeros of a linear polynomial.
A linear polynomial can have up to 1.
Yeah, at most one
It can
zeros.
have either 0 or 1.
Yes, very good. At most 1 0. Yeah, very good. So let's consider a linear polynomial 2x plus 3. So our polynomial p of x is equal to 2x plus 3. Can you find the zero of this polynomial? Everybody find the zero of this polynomial. So we know that whenever we have to find the zero of a linear polynomial, what we do is we just equate that polynomial to 0, right? We just equate that polynomial to 0, and now our aim is to find the value of x. So for that we just have to transpose this 3 to the other side. It becomes negative 3. Now what about the value of x? X will be equal to negative 3 by 2. So when we consider this polynomial 2x plus 3, this negative 3 by 2 is actually the zero of this polynomial. And can we say any relationship between the coefficients and the zero of the polynomial? See, the general form of a linear polynomial is that ax plus b. Okay, the general form of a linear polynomial is general form of a linear polynomial is ax plus b. Okay, and here in place of a we have 2, and we consider this 2x plus 3. In case of, or in place of a we have 2, and in place of b we have 3. Okay, and see, this is negative 3 by 2. What is this negative 3? Negative of b, right? X is equal to negative 3 by 2 is the zero of this polynomial. And when we compare it with the general form of a linear polynomial, we can see that this 3 is actually negative b. Okay, and this 2 is actually in place of a. So we can write it as negative b by a, right? So the zero of this polynomial, zero of a linear polynomial is actually equal to negative b by a. What is this b? B is the negative of, okay, constant term. B here is the constant term. So negative, or yeah, minus constant term divided by, what is this a? A is actually the coefficient of x. Okay, so this is the relationship between the coefficients and zeros of a polynomial in case of a linear polynomial. Okay, so when we consider any other linear polynomial, you can consider any linear polynomials. Let's consider one more example. For example, let's take 4x minus 9. Okay, let's consider another polynomial, 4x minus 9. What will be the zero of this polynomial? Okay, let's equate this to 0, and let's find the value of x from this one. So 4x will be equal to 9. In the second step, we can write it as 4x equal to 9. Then x will be equal to 9 divided by 4. Okay, x will be equal to 9 divided by 4. See, this is actually equal to negative b by a. Here, okay, here let me write the values of a and b here. 4x minus 9 is the polynomial. Okay, so in place of a we have 4 and in place of b we have negative 9. Okay, in place of b we have negative 9. So here when we consider negative b by a, this is actually negative of negative 9. Got it? Because a is equal to 4 and b is equal to negative 9 in the case of second polynomial. A is equal to 4 and b is equal to negative 9. So when we consider negative b by a, that is actually negative of negative 9. That is positive. Negative, negative, it becomes positive. So that's why here it is 9 by 4. So in case of a linear polynomial, what can we observe here? Okay. Wait a second. Here we can observe that in case of a linear polynomial, we can say that x is equal to negative b by a, or the negative of constant term divided by coefficient of x will be the zero of any polynomial p of x. Okay. So from now onwards, if you have a linear polynomial, say 9x minus 12. Okay, you have a linear polynomial 9x minus 12 and the question is to find the zero of this polynomial. Do we have to equate this to 0? No, we can just directly write it as negative b by a, but before that please make sure that you identify the values of a and b correctly without forgetting. Don't forget to take the negative sign and all. So what are the values of a and b here in this polynomial 9x minus 12? What is the value of a? What is the value of a? A is 9. Yeah, okay. And what is the value of b? B is, somebody is commenting it as 12. Is it 12? No, it is negative 12. Okay, don't forget to take the negative sign, because our general form is ax plus b and here it is 9x minus 12 means we have to consider that negative sign also. So this is negative 12. Okay, b here is negative 12. So when we consider negative b by a, that will be equal to negative of negative 12. Okay, negative of negative 12 divided by 9, that is 12 by 9 will be the zero of this polynomial, or you can just simplify it. Okay, yeah. So this is how you find the zeros of a linear polynomial. Okay, negative b by a. Zero of a linear polynomial will be equal to negative b by a. Okay, yeah. So let me give you some questions. First question is, yeah. Okay, any doubts from this one? Can we solve some questions? Okay, so the first question is, okay, first question is, okay, first question is, wait a second, okay, yeah. Okay, so let me tell you the question. Wait a second. Question is 3x plus 4 is the first question. You have to find the zero of 3x plus 4 and check whether it is satisfying the condition that the zero is equal to negative b by a. Okay, so the question is 3x plus 4 and we have to check whether it is satisfying this condition, negative b by a is equal to the zero of the polynomial or not. Yeah. So is it satisfying the condition? So 4x plus 3 is the polynomial, and let's unmute someone and ask them what is the zero of this polynomial. Yes. Abdul, what is the zero of this polynomial?
the zeroth polynomial is
Zero is
minus 3 by 4.
minus 3 by 4. Yeah, okay, so is this minus 3 by 4 is equal to negative b by a? What is the value of a and b here? A is equal to, when we consider 4x plus 3, what is the value of a? A is?
A is 4.
Yeah, a is 4 because the general form is ax plus b. So in place of a, we have 4, and what is the value of b?
B is minus 3.
Minus 3.
Minus B is minus. So B is 3.
Yeah, b is 3. Okay, yeah, very good. So here it is satisfying the condition that the 0 of the polynomial is equal to negative b by a. Very good. So any doubts, guys, about this linear polynomial and the relationship between the 0 of a linear polynomial and the coefficients of a linear polynomial? Any doubts? If you have any doubts, you can raise your hand. Otherwise, please lower your hands. Anybody, any doubts? If you have any doubts, you can raise your hands. Anybody? No. Okay. Now let's consider a quadratic polynomial. What is a quadratic polynomial? Before considering a quadratic polynomial, what is actually a quadratic polynomial? Yes, Sumaya, what is a quadratic polynomial?
Ma'am, actually I have a doubt in the last question.
Yes, okay. What is your doubt?
Ma'am, like, isn't it negative 4 by 3?
Negative 4 by 3. Okay, how do we find the 0 of a linear polynomial? We first equate that to 0, right?
Yeah.
Yeah, okay. And what is the next step? We have to find the value of x somehow. We have to find the value of x. For that, in the first step, we transpose this 3 to the other side, right?
Yes.
Okay, so after equating this to 0, we have to transpose this 3 to the other side. It becomes 4x is equal to negative 3. Okay,
Ma'am, sorry,
question
I
was
think I
3x
wrote the
plus 4.
question wrong.
Oh, okay. Yeah.
I wrote 3x plus 4.
Oh, okay. If it is 3x plus 4, yeah, if it is 3x plus 4, then it is negative 4 by 3, and here a is equal to 3 and b is equal to 4. Yeah, here also it is satisfying the condition. Okay, here also it is satisfying the condition that the 0 of the polynomial is equal to negative 4 by 3. Okay, if it is 3x plus 4, yes, it is minus 4 by 3. But if it is 4x plus 3, then it is minus 3 by 4. Yeah. Okay, yes. Yeah, any other doubts? No. Okay. Now, what is a quadratic polynomial? What is a quadratic polynomial? Yes, sir, hand raise.
Misbah.
Yes, Miss Ba. What is a quadratic polynomial?
A polynomial with the degree 2.
Very good. A polynomial with degree 2 is known as a quadratic polynomial. And can anybody define the degree of a polynomial correctly? Don't forget any words. I was like from the last classes onward, like from the first class onwards, I was stressing on that word. Yeah, what is the degree of any polynomial? How can we define the degree of a polynomial? Yes, sir, please.
Yes, Sridhya.
Yes, Ridhya, what is the degree of a polynomial? How can we define the degree?
Degree of polynomial. It is a superscript.
Or
It is written as a superscript.
superscript. Okay. Yeah, any other definitions? Here.
Yes, Leora.
Yes, okay. Yes, Leora, what is your definition of degree?
Degree of the polynomial is the highest power of a variable in a polynomial.
Yeah, highest power, not just highest power, it is the highest power of variable. Very good, Leora. So, the highest power of variable in a a polynomial is known as the degree of a polynomial. And here we have a quadratic polynomial, which means the degree here is 2. Okay, so how do we find the zero of this polynomial? In class 8th, we have a chapter named Exponents and Powers and Algebraic Expressions and Identities. All these chapters are there. And we have something called splitting the middle term, factorizing. In class 9th also it is there. So can you factorize this polynomial and find the zeros? Can we factorize this one? Splitting the middle term. Can you split the middle term? Okay, let me solve some first question. Okay, then from the second question onwards, you have to solve that. Yeah. So here we have 2x squared minus 8x plus 6. First of all, I am equating this to 0. Similar to the linear polynomial, I am equating this to 0. And I have to find the 0 of this polynomial. For that, what we have to do is, we have to split the middle term. Okay, here the middle term is negative 8. So I have to split this middle term in such a way that we have to find two numbers such that the sum of those two numbers is equal to this one, negative 8. And the product of those two numbers must be equal to the coefficient of x squared into the constant term. So it is 2 into 6, which is 12, must be the product. Okay, so we have to find two numbers such that the sum is negative 8 and the product is 12. So can you find two numbers such that their sum is negative 8 and the product is positive 12? Anybody? Can you find two numbers such that their sum is negative 8, 6 and 2? What is 6 plus 2? 6 plus 2 is 8. It is not negative 8. Minus 6 and 2. Minus 6 plus 2 is negative 4. It is not negative 8. Yeah, okay.
Okay. John Matai.
Okay.
Yeah, minus 6 or minus 2.
Very good. Negative 6 and negative 2. Very good. Minus 6 and minus 2 are those two numbers. See, negative 6 plus negative 2 is equal to negative 8. Yeah, sum of these two numbers is equal to negative 8. What about the product? Negative 6 into negative 2 and negative into negative, it will be positive. So negative 6 into negative 2 will be equal to positive 12. So the numbers are negative. If you have any doubts and answers, please send it to classroom. Okay, yeah. Okay, so minus 6 into minus 2 is 12. So the numbers are negative 6 and negative 2. So now we are going to split the middle term. Okay, so the name itself says it is splitting the middle term. So all other terms will remain the same. We are only splitting the middle term. Yeah, so the first term is 2x squared. It will remain 2x squared only. We are only splitting the middle term. And what about the middle term? It is negative 8x. We are going to split it as negative 6x minus 2x. Okay, because negative 8 is the sum of negative 6 and negative 2. So we are going to split it as negative 6x minus 2x. Okay, then the last term is 6 only. Because we are only splitting the middle term, all other terms will remain the same only. Yeah. Now we have to look for the common factors in first two terms. Okay, we have to look for the common factors in first two terms before moving to the next step. Is this algebraic expression like that? All those chapters were clear for you? Do you know how to take common factors outside? Any doubts about that one? Anybody? Any doubts about writing the common factors and all? Do you have to split it as 2 into x minus 3 into 2 into x, like that I have to write, or is it clear for you? Okay, no hand raises? Yeah, fine. So what is common between this 2x squared and negative 6x? Which term is common?
Yes. Just show. Is
Okay.
there any doubt?
2. Okay, only 2 is there?
2x.
2x is common. There is very good. After taking this 2x, what is remaining in the first term?
Ma'am, you put x
X. Then second term?
minus 3.
Yes, very good. x minus 3. What about the next two terms? What is common there? Yeah.
The next two term form is 3 or that. No, it's 2.
2. Okay, is it plus 2 or negative 2?
No, negative 2.
Okay, negative 2. Then
Then x plus
x
x plus 6, x plus 3.
x plus 3.
That's all.
X plus 3. Are you sure? X plus 3?
I think I'm not sure. Yeah.
Okay, then what is this minus 2 into this positive 3? Negative 2 into positive 3?
Negative 6.
Negative 6, but here we have positive 6. So when we open the bracket, we must get the same number, no?
Yes, ma'am.
Yeah, so it is x minus 3, right?
Yeah.
Yeah, okay, so it is x minus 3. Sir. Yeah, yes, very good, Gashom. Right answer. 2x into x minus 3. Here it is x minus 3, guys, not x plus 3. Okay, it is x minus 3. Yeah, wait a second. I don't understand how you got x minus 3. Yeah, wait a second. Wait. I will explain. Yeah, so here we were discussing about the split. Here we were discussing about splitting the middle term. Okay, here our middle term is negative 8x. We have to split that. For that, we have to find two numbers such that their product is this negative 8. Okay, not product, sum. Sum is negative 8. Okay, so we have to split the middle term. Here the middle term is negative 8x. For that, we need to find two numbers such that their sum is negative 8 and the product is positive 12. Okay, and the numbers are negative 6 and negative 2. No, negative 6 and negative 2. Okay, yeah, and we are going to write this negative 8x as the sum of this negative 6 and negative 2. That is how we split the middle term. Discard. Okay, that is how we split the middle term. Yeah, and after that, we have to consider the first two terms and we have to look for the common terms in those two terms. Okay, any common terms, anything common in those two terms. And here the common term is 2x. After taking the common terms outside, we have to look for what is remaining after taking this common term outside. What do we have? Okay. First, 0, negative. Oh, very good. Okay, you already find the zeros. Let's see. Got the answer. Alpha and beta. Okay, somebody was asking this doubt. That's why I'm repeating this. Okay, many of you got the answers. Yeah, okay, fine. Let's see. Yeah, wait. Okay. Can I? Yeah. Okay, this was the question. Wait a second. I have to write it again. Yeah. 2x square minus 8x. Wait. Can I take a break for 2 minutes? Okay, I will be back soon. Okay, 2 minutes. Yeah. Okay, I'm back. Yeah. So can you explain the steps after 2x square minus 6x minus 2x plus 6? Okay. So here we need to find two numbers such that the sum is -8 and the product is 12. Okay, and the numbers are -6 and -2. So we have to split this 2x square minus 8x plus 6 equal to 0 as 2x square minus 6x minus 2x minus 6 is equal to 0. Okay, before this I just wrote it as -2x. I think no, yeah, this was okay. So if you want, you can write it as 2x square minus 2x minus 6x minus 6. Okay, this order doesn't matter. You can write it as -2x. Is it okay now? Can you see me? I can't see. No. Okay, wait. Hello, is it okay now? Yeah, okay, fine. Yeah, okay. So we have to take the first two terms. Okay, we have to consider the first two terms and yeah, we have to look for the common factors. If you are finding it difficult, let me explain this in detail. So we can write this 2x square as 2 into x into x. 2 into x into x. Okay, we can write this as 2 into x. And this minus 6x can be written as minus 2 into 3 into x. Okay, we can write the 6 as 2 into 3 and x as just 1x. Then when we consider the next two terms, we can write it as minus 2 into x minus the last term is 2 into 3. Okay, yeah. And now let's look for the common terms. As you can see here, we have a 2 here and here also we have a 2. Okay. Then here we have one x and here also we have one x. Yeah. So 2x is common. When we consider the first two terms, there 2x is common. We have to write it outside the bracket. So 2x is common. Okay. After taking, could you explain the step again? Yeah, sure. We can write this 2x square as, if you are confident enough to find the common factors without actually expanding this, you can just find that. Okay, if you can tell me that this in this 2x square and negative 6x, 2x is common. Yeah, that's fine. Otherwise, just open this or just expand this. This 2x square can be written as 2 into, what is x square? We are multiplying x 2 times. That is x square. So 2 into x is x square, 2x square. Then when we consider the 6x, what is 6x? 2 into 3 into x is 6x. Then again negative 2x, we can write it as negative 2 into x. And here we have a negative 6, we can write it as negative 2 into 3. Okay? Yeah, and we have to consider the first two terms, and we have to look for the common factors which are present in the first two terms. So here when we consider the first two terms, we have a 2 here in the first term, and here also we have a 2 in the second term. And again, here we have one x, and here also we have an x, which means this 2x is common. It is present in both terms. That is why we are saying it is common. Okay, yeah, so 2x is common. After taking this 2x, what is remaining in the first term? Here we have one x. It was 2 into x, and we took this 2x outside. After taking that, we have one x there. Okay, x. And what about the second term? After taking 2x, we have a negative 3 here. Okay, don't forget to take this sign. We have a negative sign over here, and we have a 3 there. So it is x minus 3. Okay, it is x minus 3. That is why the first one is 2x into x minus 3. Okay. Similarly, we have to look for the common factors here. It is, here we have a negative 2, and here also we have a negative 2. So we can take that negative 2 outside. What happens when we take this negative 2 outside? Let's see. Okay, when we take this negative 2 outside, after taking that negative 2, what we have is 1x here. Okay, and here after taking negative 2, we have, okay, I can only see the logo. Is it okay now? Yeah. Could you explain the step again? Okay. Up to this step, is it okay? Any doubts till this step? Anybody, any doubts? If you have any doubts, you can raise your hand. Anybody? No. Okay. Who is this? I don't understand. Okay. So you already learned, Rehan. Okay, actually you already learned all these things in the previous classes. That's why I thought this is, yes, Rehan. From the beginning or from some steps?
No, I found out, I know, I understood the part where you have to find two numbers whose sum is 8 and product is 12.
Okay.
I understood till there, but from there onwards I didn't understand.
Okay, so we have to find two numbers such that their sum is negative 8 and product is positive 12. Yeah, and we just split this middle term. Yeah. Okay.
Can I do it from the start?
Yeah. Which middle term are we splitting? Here, which is the middle term? Here we have three terms. 2x square minus 8x plus 6. We have three terms, right? So which is the middle term? Negative 8x is the middle term, right? We have only three terms. Discard. Okay. We have only three terms, and which is the middle term? Yeah, this one. We have three numbers, and which is the middle number? When we start from 1, 1, 2, 3, 2 is the middle number when we consider three numbers. Yeah. So here negative 8x, you can't see that, I know, but still negative 8x is the middle term. Okay, which is in the middle. That's why the middle term. Now we have to split that middle term. Okay, how do we split that middle term? For that, we need...
We can take the base version.
Okay. Yeah, so here negative 8x is the middle term, and we have to take this, consider this as the middle term, and we have to split this middle term. Okay, for that we need two numbers such that their sum is this negative 8. Okay, which is the coefficient of the middle term. Which is the coefficient of middle term? It is negative 8. So we need to find two numbers such that their sum is negative 8 and their product is this one. Okay, this constant term into the coefficient of x square. Okay, constant term into coefficient of x square. Here the constant term is 6 and the coefficient of x square is 2. Therefore 6 into 2 is 12. So we need to find two numbers such that their product is 12. Okay, suppose our question was different. Okay, I have another question. Say 4x square minus say 8x plus 4. Okay, this is my question. 4x square minus 8x plus 4. Can you please unmute Rihan? Okay, here in this case, I have to split the middle term. Which is the middle term here?
8x.
8x. Yeah, negative 8x is the middle term. So I have to find two numbers such that their sum is?
Sum is minus 8.
Minus 8 and product is?
16.
16. Yeah, 4 into 4, 16. Yeah, that is how it works. Whenever we have such things, what we have to do is, we have to find two numbers such that their sum is the coefficient of middle term and product is constant term into the coefficient of x square or the first term. Okay? Yeah, up to this part it is clear, right? Yeah, and now we have to look for those two numbers. We have to consider two numbers such that their sum is negative 8 and product is 12. So what we do is, we just consider this product 12. Okay, we just consider this product 12. Yeah, and we will always write the factors of 12. That is 1 into 12. 1 into 12 is 12. And let's see whether 12 plus 1 is 13 or negative 1 minus 12 is 8. No, it is not going to work. So we will consider the second factors, that is 2 into 6 is 12. Okay, then we have 3 into 4 is 12. Yeah, and let's consider the second one, it is 2 into 6. So we have two numbers, 2 into 6 is 12. What about the sum? 2 plus 6 is 8 only, but we need negative 8. So let's change the sign to negative 2 and negative 6. And let's check whether this works or not. So what is negative 2 plus negative 6? Yeah, it is negative 8. And what is negative 2 into negative 6? It is positive 12. So the numbers are negative 2 and negative 6. Is it clear? Yeah, so what we have to do is, we always consider this product, okay, and we will write the factors of that number. Here it is 12, so 1 into 12 is 12, and let's check whether we can make this 12 sum 1 plus 12 or negative 1 negative 12, negative 12 plus 1, then 1 minus 12. No, it's not gonna be negative 8. So let's look for the second one, 2 into 6. 2 into 6 is 12, but here 2 plus 6 is not negative 8, it is positive 8. So let's change the sign to negative 2 and negative 6. So the numbers are negative 2 and negative 6. Now we have to split the middle term. Which is the middle term? The term which is in the middle, that is the middle term. So here it is negative 8x. We have to split that. We don't have to care for other two terms. It will remain the same only. We just consider the middle term. Here the middle term is negative 8x. Yeah, so we are splitting this term, which is the middle term present in the middle of the polynomial. So we have to split this one. First of all, we have to equate this to 0. We are going to find the zeros of this polynomial. So like we did before, in order to find the zeros of a linear polynomial, the first step was equating that polynomial to 0. Here also we have to equate that polynomial to 0. So we are equating that to 0. And now we have to split the middle term, which is negative 8x. How do we split the middle term negative 8x? We know that negative 2 minus 6 is negative 8. Here, negative 2, negative 6. Okay, together they form negative 8. So if it is negative 8x, along with this negative 2 and negative 6, we have to write one x there. So it will be 2x square minus 6x or 2x. Okay, you can write it as negative 6x, negative 2x plus 6 equal to 0. Or you can write it as 2x square minus 2x minus 6x plus 6 equal to 0. Okay, both of these are correct. The order doesn't matter. You can just write it as negative 6x, negative 2x or negative 2x, negative 6x. Okay, that's up to you. Yeah. So here we can write it as 2x square minus 6x minus 2x plus 6 equal to 0. Yes. Okay, now we have to take the common factors outside. I know for some of you it's very easy, but we have some hand raises and we have some chats here, okay, asking for the steps. That's why, okay. Yeah, here it is 2x square minus 6x. That is the first two terms, and here we have total 4 terms, okay, and we are just considering the first two terms together, and then the last two terms together. That is how it works. Yeah, so you have to consider the first two terms together, and then you have to consider the last two terms together. In total we have 4 terms. That's why. Yes. Okay, and now we have to look for the common factors in these two terms. Okay, we are considering the first two terms and we have to look for the common factors. We can write it as 2 into x into x. What is 2x square? 2 into, we are multiplying x 2 times. So it is 2 into x into x. Yeah. And what about this 6x? We have a negative sign. If you are confused about this negative sign, you can just write one negative 1 there, because it's not gonna make any changes there. Negative sign, you can represent it as negative 1, because 1000 into 1 is 1. Then any number into 1 is that number only. So we can just represent that number as negative 1 if you want, otherwise just leave that. Then what is 6? We can write the 6, or we can factorize 6 as 2 into 3. Then we have one x there. Okay? Yeah. Then minus 2x plus 6. We will deal with this negative 2x plus 6 later. First, let's consider the first two terms. Yeah. And now we have to look for the common factors. We have to look for the common factors in the first two terms. See, here in the first term we have a 2. Okay, we have a 2 here, and here also we have a 2. Okay, so 2 is common. In both terms we have 2, means 2 is common there. Now here we have 1x, and here also we have 1x, which means 2x is common. 2 and x is common means 2x is common there. Okay, 2x is common. After taking this 2x, we have one x here in the first term. Don't forget that x. After taking 2x, we have one x there in the first term. And what about the second term? We have a 3 and this negative 1, which means we have a negative sign and 3 there. So it must be negative 3. Okay, negative 3. Then we have the next two terms, negative 2x plus 6 equal to 0. Up to this part, is it clear? Is it clear? Rihan, is it okay now? Yeah. Any other doubts,
No.
anybody?
No.
No. Okay, fine. Now we have to look for the common factors in the next two terms, negative 2x and 6. Okay, so here we have 2x into x minus 3. That is, after simplifying the first two terms, we got this 2x into x minus 3. Now we have to consider this negative 2x and positive 6. So we can write it as negative 2 into x. Okay, then plus 2 into 3. Okay, that is equal to 0. Okay, negative 2 into x plus 2 into 3 is equal to 0. Yeah, so here it is 2x into x minus 3 itself. Now here we have to take something outside. Here we have 1 2 and here also we have 1 2. Suppose we are taking this positive 2 outside. Let's see what is happening. What is gonna happen? So we took this plus 2 outside and here what is remaining? We have one x here, but here we have a negative sign. So it becomes negative x. Okay, here it becomes negative x. And here it is plus 3. Okay, negative x plus 3. But that is not possible because after this step, we have to take something as common outside. Which means whenever we do such things, inside the brackets, the things must be seen. Here it is x minus 3. In the first one, it is x minus 3. So here also it must be x minus 3. Okay, that is the step. We have to take this x minus 3 outside as common in the next step. So somehow we have to make this a minus x plus 3 as x minus 3. So how is that possible? We have to take a negative 2 outside. Okay, instead of this plus 2, we have to take a negative 2 outside. Here it will be negative 2. So this negative sign will go and this positive sign also changes. So we get something like negative 2 into x minus 3. Okay, negative 2 into x minus 3 will be equal to 0. Now, after this step, let's see this x minus 3 is common. Here also x minus 3 is there. So, x minus 3 is common in the two terms. So, we can take that x minus 3 as common. After taking x minus 3, what we have is here we have 2x. And in the second one, we have negative 2. So, 2x minus 2, this one will be equal to 0. Okay. It was already there in class 8th also it is there in that chapter, algebraic expressions and identities. You have this one. Okay, splitting the middle term. So, I think this is clear. Any doubts? If you have any doubts, I will explain this again. Okay. If you have any doubts, please do raise your hand. Any doubts? No. Okay, fine. So here x minus 3 and 2x minus 2, both of them are equal to 0. We can equate them separately to 0. So x minus 3 equal to 0 will imply that we can equate both these factors to 0. Okay, if x minus 3 is equal to 0, x will be equal to 3. Okay, x minus 3 equal to 0 implies x equal to 3 and 2x minus 2 equal to 0 will imply that can you please remove that tagline? Okay, 2x minus 2 equal to 0 will imply that x is equal to 2 by 2, which is 1. So, x is equal to 3 and x is equal to 1 will be the two zeros of this polynomial. Okay, x is equal to 1 and x is equal to 3 will be the two zeros of this polynomial. 2x square minus 8x plus 6. Okay, we will solve more questions like this in the coming classes. Don't worry. If you are still confused about the splitting the middle term, don't worry. We will discuss this in the coming classes. Okay, please don't worry. Yeah, so here x is equal to 3 and x is equal to 1 will be the two zeros of this polynomial. Okay, and here we can see some relationship between the coefficients. Okay, I was about to take that portion, but anyways, okay, no issues. We can discuss more questions like this. Here we can see that this was the polynomial. Okay, 2x square minus 8x plus 6. This was the given polynomial and 1 and 3 were the zeros. Okay, 1 and 3 were the zeros of the polynomial. And as you can see here, what are the sum? Okay, 1 and 3 are the zeros, and when we add them, sum of zeros 1 plus 3 will be equal to 4, or we can write it as, or we can see that here it is actually equal to negative 8 by 2, or this is ax square plus bx plus c is actually the general form of a quadratic polynomial. And here in place of a we have 2, in place of b we have negative 8, and in place of c we have 6. Okay, in place of a we have 2, in place of b we have negative 8, and in place of c we have 6. Actually this is equal to negative b by a. So without even splitting the middle term, you can directly say that whenever we have a polynomial like this, we can say that minus b by a will be the sum of zeros. And what about the product of zeros? Product of zeros will be equal to c divided by a. Okay, that condition is satisfied here. See, here in place of c we have 6, and this is 6 by 2. So the product of zeros will be equal to c by a. Okay, so whenever we have two zeros, the alpha and beta, we usually call the zeros as alpha and beta. Sum of zeros, or alpha plus beta, will be equal to negative b by a. Okay, where ax square plus bx plus c equal to 0 is the general form of a quadratic polynomial, okay, equation. And alpha plus beta will be negative b by a, and alpha beta will be equal to c by a. Okay, alpha plus beta will be, or the sum of zeros will be equal to negative b by a, and the product of zeros will be equal to c by a. Suppose we have a polynomial, say 3x square minus 4x plus 8. Okay, 3x square minus 4x plus 8. Yeah, what about the sum of zeros of this polynomial, alpha plus beta, sum of zeros of this polynomial? We can see that sum of zeros is negative b by a, right? Yeah, yes, Advait. Okay, so here alpha plus beta will be equal to minus b by a. Okay, so let's write the values of a, b and c first. Here in place of a we have 3. Okay, a is equal to 3. What is the value of b? B is equal to, is it 4? It is negative 4. In place of b we have a negative 4. And what is the value of c? C is equal to 8. Okay. Yeah, so here suppose alpha and beta are the zeros. What is the sum of zeros? Alpha plus beta will be equal to negative b by a, and here it is 4 by 3. Yes, 4 by 3, and alpha beta, or the product of zeros, will be equal to c by a. Okay, c by a, and that is 8 by 3. Yes. Okay, c by a, that is 8 by 3. Yeah, so you have to learn this one, that is the relationship between the coefficients and zeros. This is the relation. Sum of zeros is negative b by a, and the product of zeros is c by a. That is the relation. In case of a linear polynomial, 0 was equal to, in case of a linear polynomial, the 0 of that polynomial was equal to negative b by a, where b was the constant term and a was the coefficient of x. And here it is not the 0, sum of zeros. Okay, sum. Okay, Hanok. Yeah. Forget about that splitting the middle term part. We can learn that. Okay, we will learn that in the next class. I thought that part was easy for all of you because it was already there in the previous classes. So that's why I haven't had more questions related to that. So, but in the next class, we can solve more questions related to that. Here, you have to learn this relation. That is, whenever we have a quadratic polynomial, ax square plus bx plus c. Okay, this is a quadratic polynomial. Whenever we have, I have not done alpha beta. Yeah, alpha and beta are actually some Greek letters. We just use that alpha beta to represent the zeros. Okay, alpha and beta are actually, they denote the zeros of any polynomial. We just use this x, y, all these variables, right? So in order to represent the zeros, we use some letters. They are just some letters, Greek letters, alpha and beta. Okay, just see this. This is alpha and this is beta. Or just forget. Okay, forget about this alpha and beta. We use them to denote the zeros of any polynomial. What we have is sum of zeros. Okay, forget about that alpha and beta. We can introduce them later. Sum of zeros. We have a quadratic polynomial. It can have at most 2 zeros. And the sum of zeros of that polynomial will be equal to negative b by a, or the negative of coefficient of x divided by, what is this a? Coefficient of x square. Okay, that is the relation. Just understand this. Sum of zeros of a quadratic polynomial is equal to negative b by a, or the negative of coefficient of x divided by coefficient of x square, and the product of zeros. Okay, product of zeros will be equal to c by a, where c is the constant term. Okay, where c is the constant term and a is the coefficient of x square. When we write the general form, a is the coefficient of x square. So it is c by a, or the constant term divided by coefficient of x square. That is the relationship between the zeros and coefficients. Okay, that's it. Forget about this alpha, beta, then splitting the middle term and all. Just leave that. Okay, we will learn that. Don't worry. I thought that part was easy for you. That's why. That's my mistake. Because not my mistake. You haven't revised your previous chapters or previous textbook. Okay, in class 9th and 8th it was there. So yeah, I thought it was easy for you, but still it's okay, we can revise. Okay, or just go back and read your all notebooks. Don't just read. Okay, try to understand what you guys were learning in class 8th, algebraic expressions and identities, and then in class 9th this polynomials chapter was there. Okay, yeah, just refresh, and I will explain this in the next class. Okay, don't worry how to find or how to split the middle term. Yeah, don't worry about that. So you have to learn this one. This one is simple, right? Sum of zeros is negative b by a and product of zeros is c by a. That is easy. That part is easy, right? I'm getting 4. In the sum of zeros from the polynomial, I'm getting 4, and this is 4, and this is, okay, here I just forgot to put one negative sign. Negative of negative 8 by 2, that is also 4, right? Okay, here we have a is 2, b is negative 8, and c is 6. Okay, when we solve this, we got the polynomial, zeros of the polynomial as 1 and 3, and the sum of zeros is 4. And here a is 2, b is negative 8, and c is 6. So in order to find the sum of zeros, negative of coefficient of x. Okay, negative of coefficient of x means negative of negative 8. Right? Negative of negative 8 divided by the coefficient of x square. What is that? Coefficient of x square is 2. So negative of negative 8 will be just positive 8 divided by 2. That is also 4. Okay, that is also 4. So here 1 plus 3 is 4. Yeah, it satisfies the condition that the sum of zeros is negative b by a. Yeah, it is correct. Okay, 4 is correct. Okay, whenever we have some polynomials like this, okay, can you find the sum of zeros here in this case? Here a is equal to 3, ax square plus bx plus c is the general form, and here a is equal to 3, b is equal to 5, and c is equal to negative 2. So can you tell me the sum of zeros in this case? Sum of zeros is negative b by a. So sum of zeros, yes sir.
Yes, Gauri.
My ma'am, can you hear me?
Yes, Gauri, you are audible.
Ma'am, so negative 5 by 3.
Yes, very good. Negative 5 by 3 and product of zeros?
C by A. So negative 2 by 3.
Yes, negative 2 by 3. So sum of zeros is actually equal to negative b by a. Okay. Product of zeros is actually equal to c by a, and here it is negative 2 by 3. So without finding the zeros, we can find the sum and product of those two zeros. Okay, here we don't know which all are the zeros of this polynomial. We can find them actually using that method, splitting the middle term method, but without finding those zeros, we can find the sum of zeros and product of zeros. That is the beauty of this one. Okay, that's it. The relationship between the sum of zeros and the coefficients. This is the relation, and we have to learn that splitting the middle term. In the next class, we can learn that one. Okay, is this relation clear? Sum of zeros negative b by a and product of zeros c by a. Is that clear? Any doubts about that one? Okay, so when you come for the next class, please just go through this one. Okay, splitting the middle term, and then we will learn that. Don't worry, it is very easy. Okay, I will make that easy for you. Don't worry about that. Yeah, now it's time for exam. And yeah, sir, exam.
Okay, for 1 minute.
Okay, guys, 1 second. So relationship, just you can using that one, you can solve the problems, or otherwise, yeah, linear polynomial, 0 of a linear polynomial is actually equal to, here in case of a linear polynomial, 0 is equal to negative constant term by coefficient of x. 0 is equal to, but when we consider a quadratic polynomial, sum of zeros is negative b by a. In case of linear, it was negative b by a was equal to the 0, and here sum of 0 is equal to negative b by a. That is the difference. Yeah. Okay, exam. Okay, so did you get the link for exam? These are the questions. Just go back. Okay, you know how to find the link, right? Just go back or just minimize your zoom, and there you can see a blue button. Sum of zeros here. Sum of zeros of 3x square plus 5x minus 2s. That is the first question. Then, which of the following is a zero of the polynomial x squared plus 7x plus 10? Okay, if you are finding this one, splitting the middle term, I didn't still get. Oh, okay, just refresh your page, then you will get it. Okay, I did. Okay, who is that? Everybody got this link? Who is that?
Shafia.
Shafia. Okay, everybody got this link. Is there anyone who is still struggling to get the link? Please raise your hand. Okay,
Yes,
one.
Haripriya.
Wait, 1, 2. Let's count. 1, 2. Only 2. Only 1. 1 and Shafia, right? Haripriya and Shafia. Okay. Shafia and Haripriya, just refresh your page and then minimize your zoom, and there you can see a blue button. If it is not there, just refresh your page, then you can find that. Okay.
No, it's uploaded.
Now it's uploaded. Yeah, okay. Haripriya, did you get?
Haripriya.
I'm not able to open my app. Okay. Yeah, which of the following is a zero of the polynomial? Okay, guys, let me give you a clue. What is the zero of a polynomial? That value which makes the polynomial zero, right? So just think about this as that way. Okay. Yeah. I was planning because I was planning to cover that portion, splitting the middle term. So I thought you guys will solve this using splitting the middle term method. But since that method is difficult for many of you, you can just use this one. Okay, the definition of 0 of a polynomial. Any value which makes that polynomial 0, or the point at which the polynomial becomes 0. So just put the values and try to find. Trial and error method. You have just 4 options. So just try to put those values in this one. Yeah, and then you will get it. Then product of zeros of the polynomial 2x square minus 8x plus 6 is. Then if one zero of the polynomial is negative 2, find the other 0. One 0 is given, you have to find the next 0. Here also trial and error method, or the other one, like you have this relations, sum of zeros, product of zeros. So one number is there, what about the other one? Sum of zeros is something, and yeah, that's it. Then given that x minus 2, okay, in class 9th we have this factor theorem. Given that x minus 2 got full, oh very good. Okay, x minus 2 and x plus 3 are the factors. So what was factor theorem? If x minus a is a factor of a polynomial, then dash is a 0. That was one theorem. Yeah. Since many of you have fully forgot about this 9th and 8th maths, I don't know if you will get marks for this one, but somebody is commenting I got full marks. Yeah, 10 out of 10. Yeah, then it's fine, but don't worry, I will explain. Okay, wait. You will get only 10 minutes for this exam, okay? Yeah. I got 10. Okay, so many of you are scoring 10 out of 10. Yeah, very good. Those who are done, leave, or do we stay? Okay, if you don't have any doubts about this question, you can just leave. Otherwise, just stay. Okay. If you got full marks and you don't have any doubts about solving this, you can stay. Okay. I got, okay. It's okay, it's okay. I will discuss the answers. Is there anyone who is still attending the exam? Please raise your hand. Yeah, already answered. Okay. Yeah, okay. Done. 10 out of 10. Okay, very good. So let's discuss the answers. Okay. Yeah. Sum of zeros. Here we have a polynomial, and sum of zeros of a quadratic polynomial is equal to, we have the relation, sum of zeros is equal to, just comment your answer, sum of zeros is equal to the relation c by a or negative b by a. Sum of zeros. Negative b by a. Yeah, negative b by a. Sum of zeros is equal to negative b by a. And here the value of a is 3, the value of b is 5, and the value of c is negative 2. See, it is negative 2. But here we just need negative b by a anyways. So it is negative 5 divided by 3. So option 1 is the correct answer. Negative 5 by 3 is the correct answer. Everybody got this right? Negative 5 by 3? Yeah, fine. Now the second one, which of the following is a 0 of the polynomial x squared plus 7x plus 10? Which is the correct option? 1, 2, 3 or 4? 2, 4. Okay, so what you can do is, we have this relation, or we have this definition. If p of x is a polynomial and we have something called k, and at this point the value of this polynomial is 0, p of k is equal to 0, then k is known as the 0 of that polynomial. So what you can do is, name this as p of x. Okay, this polynomial is p of x, and here we have 2. 2 is the first option. Try to find P of 2. What is P of 2? What you have to do is, wherever you see this x, replace that x with 2. So this will be 2 square plus 7 into 2 plus 10. And let me give you a clue. The number must be, or the polynomial at this value or at this point, the value of this polynomial must be 0. Here, in this polynomial, we don't have any negative signs. It is x square plus 7x plus 10. So when we substitute this 2 and 7, we are going to get some big numbers. It is just plus plus plus. So it's better to put this negative values. Okay, we can simply ignore this 2 and 7 from this one. Yeah, 2 and 7 from this one, and try to substitute the other negative values. So let's substitute let's find P of negative 5. Okay, P of negative 5 is negative 5 square plus 7 into negative 5 plus 10. What is negative 5 square? What is negative 5 square? 25. Is it negative 25? No, it is 25. Yeah, 25 minus 7 5s are 35. Right? But it is negative 35. 7 into negative 5 is negative 35 plus 10. And this is equal to 25 minus 35 plus 10. That is equal to negative 10 equal to 10. 20. 0. It is 0, right? What is negative 35 plus 10? According to board mass, we have to do this negative 35 plus 10, and it will be negative 25. So 25 minus 25, which is 0. You will get the answer as 0. Okay. So this is the correct answer. Negative 5 is the correct answer. Okay, negative 5. How many of you got this negative 5 as the correct answer? Many of you. Okay, good. Negative 5 is the correct answer. Now the next question is product of zeros of the polynomial. We have the relation product of zeros is equal to negative b by a or c by a. Is it negative c by a? No, it is c by a, right? Yeah. Product of zeros is equal to c by a. And what is the value of c here? C here is 6, and what is the value of a? A is 2. So 6 by 2, and we will get 3. So 3 is the correct answer. Product of zeros is 3. Yeah, 6 by 2 is 3, right? Yes. So the product of zeros is 3. One zero of the polynomial is negative 2. Find the other zero. Which method or which identity or which thing we can use here? Which property we can use here? Okay, we know that sum of zeros. Okay, 1 by 3 is the answer. Let's see. Sum of zeros is equal to b by a, or negative b by a is the sum of zeros, right? Yeah, what is the value of b here? It is 5. So negative 5 by 3 is the sum of zeros. And one zero is given as negative 2. So when we add the other zero, so the other zero, let the other zero be x. Okay, x is the other zero. When we add them together, we must get negative 5 by 3, right? That is the relation. Sum of zeros is given as negative b by a, and the one zero is given as negative 2. So when we add this negative 2 with the other 0, we must get negative 5 by 3. Then only the condition will be satisfied. So just try to solve this. We will get it as x is equal to negative 5 by 3 plus 2. Okay, we are transposing this one. So when we take this 2 to the negative 2 to the other side, we will get plus 2. So this will be negative 5 plus 2 into 3, which is 6, divided by 3, that is 1 by 3. So 1 by 3 is the correct answer. Any other methods? Everybody used this method or any other methods? Everybody used this one. Yeah, knew we can do something like this, but I didn't go for it. Why? I used a relation. Yeah. So you can use this one or the other one. Product of zeros is c by a. You can use that one also. Okay, product of zeros is c by a. You can use that one also. So product of zeros is C by A means negative 2 by 3, and one number is given as negative 2. So which is the next number? It will be 1 by 3. Yeah. Yes. So you can use this one. Product of zeros or sum of zeros. That's it. Okay, here, this one. We have something called factor theorem, and it says that if x minus a is a factor, if x minus a is a factor of the polynomial, then a is a 0. Okay, if x minus a is a factor of the polynomial, then a is a 0. There was one theorem like this in class 9th. If x minus a is a factor of the polynomial, then a is a 0 of that polynomial. Again, if a is a 0, then x minus a is a factor. Okay, so here x minus 2 and x plus 3, they are given as the factors. Okay, before moving to that, if x minus a is a factor, then a is a 0. What happens if x plus a is a factor? If x plus a is a factor, dash is a 0. If x plus a is a factor, negative a is a 0. Yes, negative a is a 0. Okay, if x plus, okay, what you can do is just go back and after the class, read your class 9 notebook or textbook, polynomials. This is just continuation of that chapter. So without knowing all the theorems, it will be very difficult. So just go through those chapters and all. Yeah, so if x plus a is a factor, negative a is a 0. So here x minus 2 is a factor means 2 is a 0, and x plus 3 is a factor means negative 3 is a 0. So 2 and negative 3, these are the zeros. So the option 3 is the correct one. 2 and negative 3, they are the factors. Okay? Yeah.
Yes, Anega.
Yes, Anaka. Anaka, please unmute.
This slide, I have a doubt in it.
Which one?
Ma'am, can you hear me now?
Yes, yes.
The previous slide.
Previous slide. Okay. Yes.
Ma'am, in here, why we can do the splitting and
Splitting the middle term.
we can get an answer. But when I'm getting, I got like minus 5 by 3. Yeah.
Minus 5 by 3. So which was your method? Splitting the middle term.
Yeah.
Splitting the middle term. Okay, so you have to find two numbers such that sum is 5 and product is negative 2 by 3. So the numbers were, okay, wait, sum is 5 and product is negative 2 into 3, which is negative 6. Okay, sum is 5 and product is negative 6. So the numbers are,
Can we take like 6 and minus 1?
6 and minus 1.
Yeah.
Okay, 6 and minus 1. 6 minus 1 is 5 and 6, yes, okay. Then, okay, 1 second. 3x square plus 5x. Okay, 3x square plus 5x. Can you please read that question? 3x square plus 5x.
Yeah. Minus plus 5 is minus 2.
Yeah, 3x square.
Plus 5 is minus 2.
Yeah, 3x square plus 5x minus 2. Yeah, and we have to find two numbers such that sum is 5 and product is negative 6. Okay, so the numbers are 6 and negative 1, right? Okay, so 6 minus 1 is 5 and 6 into negative 1 is negative 6. Okay, so we can write it as 3x square. You just write it as minus x plus 6x minus 2 or plus 6x minus x. This is how you write this, right? Or plus 6x minus x minus 2.
Yeah.
Yeah, this one is fine. Yeah, and what is common?
No, I did like 3x square plus.
Yeah, okay, that is what I'm asking. Plus 6x minus x minus 2. Okay.
Yeah.
And what is common in the first two terms?
3 and x is common.
3 and x is common, so 3x. Wait a second. Okay, 3 and x is common, so 3x. Okay, after taking 3x, We have
X plus 2 is left.
Yes, x plus 2 is there. Yeah. And here also we must get x plus 2, right? For that, we have to take something outside. What is that?
1.
Is it just 1 plus 1 or negative 1?
Negative 1.
Yes, negative 1. Yeah. Then x plus 2 is common. So x plus 2 into 3x minus 1, right? We can equate each factor to 0.
Okay.
So x plus 2 equal to 0 implies x equal to negative 2 is a 0. That is already given. Negative 2 is a 0. What about the other one? 3x minus 1 equal to 0 implies 3x equal to 1 and x equal to 1 by 3.
So I actually substituted with the alpha and beta. That's why I got the answer as 5.
Okay, you can equate each factor to 0. Then you will get the answer. Okay.
Okay.
Yeah.
Yeah.
Yeah. Okay.
Thank you.
Yes. Any other doubts? Can you explain once more? Which one? I think this one, right? Regin, this one. Okay. Yes. Okay. So we have a theorem. Okay. In class 9th, we have a theorem. If x plus a is a factor of a polynomial, say, okay, 1 second. Theorem is x minus a is a factor of a polynomial. Okay, x minus a is a factor of a polynomial. Then a is a 0. Okay, a is a 0. For example, if x minus 2 is a factor of a polynomial, then 2 is a 0 of that polynomial. Then x minus 3 is a factor of that polynomial means 3 is a 0 of that polynomial. Factor means here see. We can express that polynomial as the product of something. This is a factor. Here x plus 2 is a factor and 3x minus 1 is a factor. That is the meaning of this factor. Here x plus 2 is a factor means negative 2 will be a 0. See, x plus 2 is a factor. It implies that negative 2 is a 0. Okay, that is the theorem. If x plus 2 is a factor, then negative 2 is a 0. Or x minus a is a factor means a is a 0 and x plus a is a factor means negative a is a 0. Okay, so here x minus 2 is a factor means 2 is a 0 and x plus 3 is a factor means negative 3 is a 0. So 2 and negative 3, this is the correct option. Understood. Okay. Any other doubts? Okay, fine. See you all in the next class, and when you come for the next class, please make sure that you just go through the other chapter, class 9th, polynomials. Okay? Yeah. See you all in the next class. Until then, bye-bye. Take care.